The recent discovery of a new comet, designated C/2025 V1 Borisov, has captured the attention of astronomers and skywatchers around the world due to its unusual characteristics, and its coincidental arrival shortly after the detection of the mysterious interstellar object 3I/Atlas. This comet, spotted only a few days before its closest approach to Earth, has become a subject of speculation, comparison, and scientific interest. While some have drawn connections between the new comet and the current interstellar visitor streaking through our solar system, researchers emphasize that the similarities are superficial and do not indicate any shared origin. Instead, the evidence overwhelmingly supports the conclusion that C/2025 V1 is a native resident of our solar system, despite a few intriguing features that may initially seem out of the ordinary. C/2025 V1 was discovered on November 2nd by Gennady Borisov, a Crimea-based amateur astronomer renowned for finding unusual celestial objects. Borisov became widely known in 2019 after identifying 2I/Borisov, the second confirmed interstellar object ever observed entering our solar system. His past discovery naturally caused a stir in the astronomy community when a new comet bearing his name appeared, especially given the timing, just months after the detection of 3I/Atlas, an extremely fast interstellar body with highly unusual properties. The coincidence prompted some researchers and astronomical enthusiasts to wonder whether C/2025 V1 might belong to the same category of cosmic visitors or share some deeper connection with 3I/Atlas. However, ongoing observations have shown that these parallels are only surface level. On its current trajectory, C/2025 V1 will make its closest known approach to Earth on Tuesday, November 11th, at a distance of 64 million miles, 103 million kilometers. While this may sound close in astronomical terms, it is still about 270 times farther away than the Moon. There is no potential threat to Earth, and the comet's passage is expected to be a relatively quiet one from a planetary safety perspective. After passing by Earth, the comet will continue on its path toward the Sun, reaching perihelion, the point where it is closest to the Sun, on November 16th. As is typical for many newly discovered comets, scientists expect its brightness and appearance to evolve as it approaches the Sun and reacts to increasing solar radiation, though its initial faintness suggests it may never become bright enough to see without equipment. At present, C/2025 V1 has an apparent magnitude of roughly 13.8, far too dim to be visible to the naked eye. To detect it, observers must use a high-quality telescope or strong stargazing binoculars, especially during early dawn hours when the comet is most prominent against the sky. It currently resides in the constellation Virgo, a region often targeted by amateur astronomers due to its rich field of galaxies and deep sky objects. The Skylive.com and similar astronomy platforms have been providing updated charts, coordinates, and visibility windows to assist observers hoping to catch a glimpse of this faint but scientifically valuable comet. The similarity in name to Gennady Borisov's earlier interstellar discovery has led some people to jump to conclusions about the nature of C/2025 V1. This confusion grew further when Avi Loeb, a well-known astrophysicist from Harvard University famous for his theories about interstellar objects and extraterrestrial technology, described the new comet as nearly interstellar in a recent blog post. Loeb's comments sparked debate about what qualifies an object as interstellar and whether C/2025 V1 might be misclassified or misunderstood. The key factor, according to astronomers, lies in the comet's orbital eccentricity. C/2025 V1 exhibits a high eccentricity, meaning its orbit is more elongated and less circular than most typical comets that originate within the solar system's traditional boundaries. A perfectly circular orbit has an eccentricity of 0, while a highly stretched, nearly straight orbit approaches a value of 1. Interstellar objects, which enter the solar system from beyond, tend to have eccentricities greater than 1, indicating they are not gravitationally bound to the Sun. The new comet's orbit does not exceed this limit, but its eccentricity is unusually high for a solar system object, giving it a nearly linear inbound trajectory. This feature is one of the primary reasons some observers compared it to 3I/Atlas, whose eccentricity and velocity clearly identify it as an interstellar traveler. Despite this similarity, scientists note that eccentricity alone cannot define an object's origin. Many long-period comets originating from the distant Oort cloud, a vast spherical shell of icy bodies surrounding the solar system, also have extremely elongated orbits that only appear nearly straight when approaching the inner solar system for the first time in millions of years. Such comets are native to our cosmic neighborhood, even if they behave in ways that superficially resemble interstellar objects. Measurements of C/2025 V1's orbital parameters show that its trajectory fits the pattern of a solar system comet, not an interstellar interloper. Its speed, direction, and long-term orbital calculations all reinforce the conclusion that it is gravitationally bound to the Sun and therefore part of our system's natural population of icy wanderers. Another aspect fueling speculation is the comet's physical appearance. Early images suggest that C/2025 V1 either lacks a prominent tail or possesses an unusually subdued one. Comet tails form when the Sun heats a comet's ices, causing gases and dust to vaporize and stream outward. The absence of a bright tail could indicate that the comet is composed of less volatile materials, is still too far from the Sun for significant sublimation to occur, or is simply too faint for typical tail features to appear clearly in early observations. Avi Loeb and others pointed out that 3I/Atlas also displayed an unexpected lack of a well-defined tail despite its proximity to the Sun in some observations, leading to visual comparisons between the two objects. However, the lack of a tail is far from conclusive evidence of an interstellar origin. Many comets exhibit irregular or weak tails depending on their composition, activity level, and the angle from which observers view them. Comet activity can also fluctuate as it approaches the Sun, meaning C/2025 V1 may still develop a more noticeable tail in the coming days. The timing of the discovery has also contributed to public fascination. Finding a comet only days before its closest approach may seem alarming, but this is actually common with smaller or fainter comets. Many such objects are only detected once they drift within reach of ground-based telescopes, capable of spotting their dim glow. The fact that a skilled observer like Borisov detected it so quickly is a testament to the increasing sensitivity of modern astronomical equipment and the dedication of amateur astronomers who contribute significantly to the field of comet discovery. In recent years, amateurs and professional sky surveys alike have uncovered a wide range of comets that were previously too faint, too distant, or too small to detect with older technology. The discovery also serves as a reminder of how dynamic and unpredictable our solar system can be. Comets remain relics of the early solar system, preserving materials that date back billions of years. Each new comet offers scientists an opportunity to learn more about the conditions in the primordial cloud of gas and dust that gave birth to the Sun and planets. Their compositions, trajectories, and activity patterns provide clues about how the solar system formed and how it continues to evolve. C/2025 V1, despite its faintness and unthreatening path, is no exception. Observations and measurements collected during its passage will likely contribute to ongoing studies of cometary physics, orbital dynamics, and the processes governing icy bodies in the outer solar system. The comparisons to 3I/Atlas also highlight the growing scientific interest in interstellar objects. Since the first detection of 1I/Oumuamua in 2017, astronomers have realized that visitors from other star systems may pass through our solar system more frequently than previously believed. Each one offers a rare chance to study materials originating from entirely different stellar environments, potentially holding information about planets, stars, and cosmic processes far beyond our own. As such, the desire to label new discoveries as interstellar is understandable, even if it is often premature. In the case of C/2025 V1, the weight of evidence firmly places it within the solar system's native population, but the excitement surrounding its features reveals just how eager the scientific community is to identify and study interstellar arrivals. As C/2025 continues its journey, astronomers will monitor its brightness, tail formation, and trajectory. Though it may remain too dim for casual stargazers, dedicated observers with proper equipment may still have the opportunity to witness this rare and fleeting object before it disappears back into the vast expanses of the outer solar system. Its brief visit underscores the incredible diversity of celestial objects that populate our cosmic neighborhood, some interstellar, others homegrown, and reminds us that even today, in an age of advanced technology, the universe still holds countless surprises waiting to be discovered.